Good morning, students. All right, we are still on Module 14, the deep sea. We're continuing. So this is the last half of 14B. Remember, we started a little bit of filling in some of the blanks on 14B at the end of last week's lecture. So we're on page 94 of your student lab book, and we're going to start somewhere kind of like down toward the just beyond the middle right there where it says hydrothermal vents. So we'll be starting that today. All right, today's lecture is going to be a little shorter. Hooray, right? But that's because you have an assignment, and that is to watch a video called The Deep Sea. It was made by the IMAX creators, and I have that for you. I cannot embed it in this particular presentation, and the reason is it's probably got some copyright issues and things like that. So instead of doing that, I'm going to send you a video link. It's not a link, it is the actual video, which you should be able to play on your computer with any video player you have on your computer. Okay, so I'll send it in a separate email, and what you'll do is just click on it. It should open up. If you have trouble opening it, if your video player won't play it, for instance, then I think all you'll need to do is to download a free program called Bandicam, and I'll write that down for you. And then you should be able to watch it just fine. Or you could also look for it on Netflix or Prime Video or something like that. It is not available for free on YouTube. All right, so you'll need to find it. I own the movie. I have the disc of it, and that's why I was able to record it, because I already own it, and y'all can watch it. I just ask you not to send that off to other people or anything. I don't want to infringe on anybody's rights there. But you could possibly, like I said, find it streaming somewhere, Netflix or one of those places like that. So if you want to do it that way, that's fine. All right, the next thing we have to talk about is that we need to have a live Zoom classroom meeting, not for the lecture. So what I'll do, this will be for next week. That's going to be the 21st, so April 21st. We'll go ahead and have a Zoom classroom, I hope, unless things break down before then. And what we'll do is at 10:30, we'll get together. I'll send out the invitation, and then y'all can come. Sure, you've been doing it for other classes. You understand how it works now. You probably know more about it than I do. And we'll get together and just have a time of question-answer kind of a thing. It won't be for the lecture, however, because that I'm going to go ahead and send recorded to you. So I'll send that recorded to you by Monday, and then Tuesday morning, probably just for a half hour or so, we'll get together, and we'll talk also about the quiz situation, trying to get those in. I'm working to try to get those on the Google Classroom, and so far I've been able to do it with one of my classes. Some of the students have responded to it, so we'll see what's going on with that. All right, so very good. Let's finish up now. Remember, you're on page 94 of your student activity book, and we are going to proceed. Here we go. Not quite yet. So we're starting with these hydrothermal vents, and they're real interesting spots deep down in the ocean. All right, so they form where mid-ocean ridges create a hot spring. So that's the key word right there, hot. All right, they're actively spreading the rift zone where hot water spews up from the crust. How is the water hot? It's being heated from below by the magma of the earth, right? Just like almost like a volcano type of a thing, but it's just heating the water. So therefore the water's getting hot. Just like we have hot springs above the land, we have hot springs under the ocean. There's a unique ecosystem down there, various life forms. We'll be looking at a couple of things here. There are chemicals that are coming out, okay, and they're being spewed out. Some bacteria can use those to make organic materials. It's like photosynthesis, but because it's not using light to synthesize and make stuff, it's using chemicals. This process is called chemosynthesis. All right, so on your blank for chemosynthesis, you can say that bacteria make organic materials from chemicals. All right, so therefore they are primary producers, similar to what plants would be like or blue-green algae would be like above the water, or floating on the water. Then we will see that this can happen down deep as well. And we'll actually explore this a little more as we move on. All right, remember, if you need to write any of this down and I'm going too fast, you can pause the video. This is a picture of what a hydrothermal vent will look like. We can see how there's a rift over here that's spreading right here. And so we have magma warming up the water above it. And the smoke, we'll see this in a minute, that smoke coming up is not smoke, it's actually minerals. All right, so you can see all these different minerals right in here that are coming up. And those are some of the chemicals that the bacteria are using. So you can see how we have, yes, some seawater can come in from other locations. It gets really quite elaborate here. It's interesting how we figured some of this out because they are very, very deep in the ocean. Here's our solar photosynthesis right here. Here's our chemosynthesis. So you see the difference in the chemical reaction going on here. And you just need to understand the concept of chemosynthesis. You won't need to know this chemical equation like you do need to know the chemical equation for photosynthesis. There are these vents that we call black smokers. The minerals, when they hit the hot water, when the hot water hits the cold water, then the chemicals will sort of precipitate almost immediately. So it looks like smoke. It's not actually smoke. It's chemicals, right? So we're going to see actually a video of this. Here's a picture of one. So it definitely looks like smoke, right? We're going to watch this video that's going to explain a little more to you.
This is video of a hydrothermal vent at the bottom of the deep sea, courtesy of the National Oceanic and Atmospheric Administration. You can see on the right side of the video that the vent is spewing out a lot of black smoke. This particular vent has been nicknamed the Inferno vent, and it is part of a class of hydrothermal vents called black smokers. Although the average black smoker has a temperature of about 250 C, this is a particularly hot one with the surrounding water temperature at almost 350 C. Now the smoke that you're seeing coming from this vent isn't really smoke at all. It's actually powdered minerals. You see, the water at the base of this vent is very hot because it's being heated by the magma. This causes minerals to dissolve from the magma into the hot water. As this hot water rises, it meets the cold water of the deep sea, cooling to the point where the minerals can no longer stay dissolved, so they precipitate out as a powder. Now, as the note on the video tells you, what looks like flames in this video aren't really flames at all. They are in fact an illusion brought on by the gas bubbles that are rising out of the vent. The light that's being used to film this video is playing off those gas bubbles, making it look like they're flames. Despite the heat they generate, hydrothermal vents support a very diverse ecosystem. You can find all sorts of interesting creatures around a hydrothermal vent, including crabs. This particular crab, for example, has decided to perch on a chimney of a formerly active hydrothermal vent. He likes his perch so much that when this probe from the submarine tries to take a sample from the chimney, the crab actually attacks it as an intruder. While the crab is fighting the submarine probe, notice how pale it is. This is very common among creatures that live near hydrothermal vents. Crabs found in the photic zone are usually brightly colored, but down here you can't see colors, so most organisms near hydrothermal vents are fairly pale. While there are exceptions to this rule, like all rules in biology, in general, the animals near hydrothermal vents do tend to be pale.
All right. Also down in this region we have these incredibly cool creatures living down by these hydrothermal vents. They're called giant tube worms. They are crazy looking. They thrive in this. They live symbiotically with the chemosynthetic bacteria. They're big. They're gutless. We'll see in a not chickens, but they're gutless and they don't have a gut. We'll see in a video in a minute the reason for that. It has to do with the way they're feeding there. They pull oxygen for bacteria, and the bacteria make food for the worms. Okay, so there's this beautiful symbiotic relationship. I'm going to show you a little bit about their makeup. Here's actually a picture of them. So that this top part right here, we'll see in a minute, is like a feathery sort of filter feeder apparatus, and then the tube is actually a hard shell type thing. So you can see right there the worm tube is a shell, and then this creature is living inside of it. Okay, and that plume type activity is for filter feeding. And here's a close-up picture just because they're so cool looking. It took us, we didn't find these for a long time because we were never able to get down that deep to the thermal vents, so, and down in crevasses and things like this. So it took a while. Let's watch a little video about these guys.
This video from the National Oceanic and Atmospheric Administration shows you different kinds of worms that live near hydrothermal vents. These worms are called tube worms, and they get their name because they manufacture a tube in which to live. The white cylindrical structures you're seeing here are the tubes. The red plume you see coming out of the tube is a filtering device that the tube worm uses to collect chemicals from the seawater. It transfers those chemicals to symbiotic bacteria that are living inside the tube worm. Those bacteria use the chemicals in chemosynthesis to produce carbohydrates that the tube worm can then use to get energy. Because they get their carbohydrates directly from symbiotic bacteria, tube worms don't need mouths or guts because they don't technically feed. They just collect chemicals to give to the bacteria. In case you're wondering, the plume is red because it is filled with blood that contains hemoglobin, the same protein found in our blood. Sulfide worms also live near hydrothermal vents, and you can see they are quite different from the tube worms I showed you earlier. These worms are very territorial, and if you look in the area being pointed out, you'll actually see two of them fighting over territory. The organisms that live near hydrothermal vents are amazing, and they're the focus of much research since little is known about them.
Okay. So earlier when I said that these tube worms, that's the feeding apparatus, it's really not, like it said in the video, not feeding, but just absorbing or filtering really would be the better way of saying that. All right. Also, I wanted to tell you about right here, they can actually pull this in, so if they feel threatened or something, which down in the deep's not very often, they can pull it into the tube. So I had my younger students would take a straw and a feather and poke it out, and then they could pull it back down into the straw. That was kind of our model of a tube worm right there. Okay. We also have cold seeps down in the ocean. So this is where there is cold water that seeps out. So on your blank for cold seeps, go ahead and say that cold water is seeping out. It's just squeezing out. It's not being heated from below, but it's just coming from below. Sort of like a spring, like a cold spring coming out. And some of these cold seeps will have zinc sulfide seeping out with them, which then looks like white smoke coming out. So we call those the white smokers. So on your blank for the white smokers, write a cold seep with zinc sulfide with it. Okay, something like that. We find these in Japan, the Gulf of Mexico. All right, so we'll see those there. Is there such a thing as photosynthesis down in the deep sea? Well, it turns out there is. Very interesting. Once again, we're going to be talking about my favorite thing, right? We're looking at microorganisms. We're looking at bacteria. Always saving the day, our bacteria. So we have these type of bacteria called green sulfur bacteria. We have found them in the plumes of black smokers. So the black smoke, remember, so these would be hot. And then that black smoke is coming up, and we have found bacteria living in that black smoke, those minerals. And they can use something called bacteriochlorophyll to perform photosynthesis. It's kind of cool. They're actually receiving a very tiny amount of light. So it's highly sensitive to light. They can capture a single photon of light every 8 hours. They have these things called chlorosomes or light funnels. It gets real kind of complex when you look at the biochemistry that's taking place there. But it brings in that little photon, and that little photon will go through a cascade of biochemical events, then producing what photosynthesis produces. They can even collect black body radiation. All living things give off a certain amount of infrared light, including these things down there at the bottom of the ocean. And they can actually use that to go through the process. That's pretty cool stuff. And because they're giving off heat. So that's where they get that black body radiation. All right, one of the really fascinating spots when we're talking about the deep sea is the deepest place on the planet. Okay, so this is the Mariana Trench, and it is known as the deepest spot on the planet under the ocean. And you can see, let's see, where is it? Off of Japan right there, north of Australia. And then it just shows us here that it's underneath where the Marianas Islands are, so how deep is it? This over here is showing you how tall Mount Everest is. So from the ground, Mount Everest is this tall. And if we took that, look, the Marianas Trench is actually deeper than Mount Everest is tall. Okay, so we can see there on the right here, we can see where the whales live here. Here's where the Titanic had its final resting place. We have actually, I'm going to show you a video in a minute of a sub that has gone down deep into the Marianas Trench. What is this supposed to be? Okay, so this is the Matterhorn. This is Denver. Okay, so we can see that is very, very deep. It's deeper than what our commercial airplanes fly at. And what's happening here, we know whether we have some subduction going on, you know, so one of the plates hitting another plate, and this one's going down into there, and in the process of going down, it makes this little trench right here. Okay, and here's our Mariana Islands right here, which are on a ridge which come above that, which makes sense because that Pacific plate is pushing on that Philippine plate, and it's causing that pressure to build those islands over there, furthermore making the trench on the other side. And this is another representation of it, so you can see the crust being pushed down here, our trench being created, and our islands being created right over here. All right. So trench life, what's going on down there in the trenches? Yeah, some crazy stuff. All right, we have these some of the most bizarre creatures. We've talked about some of them, right? And some of these guys are way down here. Some on the plain, and then some down deep in the trench right there. Some of the weird ones. Now we have a submarine that has gone very deep. Let's watch a little video about it.
This is Alvin. He is a human-occupied vehicle owned by the United States Navy and operated by Woods Hole Oceanographic Institute in Massachusetts, a global leader in the study and exploration of the ocean. As Alvin descends, sunlight slowly fades away, which is why he's equipped with metal halide and LED lights to navigate in complete darkness. He is the only deep-sea submersible capable of carrying 2 scientists, as well as a pilot. Much like a space shuttle that withstands the vacuum of space, his titanium construction allows him to withstand the crushing pressure of the deep ocean. A typical dive measures 4,500 meters and lasts for about 6 hours, although its life support system will allow passengers to remain underwater for up to 72 hours in emergency situations. He also has 3 12-inch thick portholes installed on the port side, starboard, and bow for direct observation, with several video and still cameras mounted on the outside. Using its reversible thrusters, he is capable of maneuvering around rough topography, hover in place, or rest on the seafloor. Two hydraulic robotic arms mounted on the front allow scientists to collect biological and geological samples and to conduct research in real time. Since he was built in 1964, Alvin has successfully made over 4,400 dives and is capable of surveying 63% of the global ocean. He has made numerous feats of discovery, such as locating a lost hydrogen bomb in the Mediterranean Sea and finding the first hydrothermal vents off the coast of the Galapagos Islands, and most famously for researching the wreck of the RMS Titanic. Once research is completed, Alvin takes another 2 hours to resurface. Alvin is still in use today and remains state-of-the-art due to consistent upgrades and reconstructions.
Okay, I hope you could understand all that. That sound was a little weird on that one. All right, so I was saying how it goes. So Alvin is the one that went down to the deep sea, not to the Mariana Trench. Okay, so it went down to sea, and that's where we found out about the hydrothermal vents. We've got those samples that were collected. We were able to find out what was in those black smokers and stuff like this. So many years later, I don't know if you remember this guy, if you recognize this guy on the left here. His name is James Cameron, and James Cameron was the guy who made the movie Titanic. So he's a movie director. And he used Alvin and he saw the film from the Alvin that went down and found the Titanic, right? It's not as deep as the Mariana Trench. And from that time on, he was very fascinated with the deep sea. And so it made it a personal challenge of his to find a way to get all the way to the bottom of the Mariana Trench. Now, usually everybody told him he was crazy. There was no way that was going to work out that way. But he was very rich. He made lots of money off that movie, for one. And he helped to develop this thing here called the Challenger Deep. So it's a sort of like another type of what's a submersible, kind of like a submarine, but look how it goes down kind of instead of horizontally, kind of vertically here. And here he is down here. So you have to, the pressure down here is so much that it would crush the Alvin. It would crush other normal submarines. And so they had to come up with this design that was uncrushable. And apparently it worked. Do we have a date on here, a year that he went down here? But he did. So the guy that went down was James Cameron. He was the one that went down to the bottom of the Mariana Trench, which is pretty cool stuff. And so it mentioned it also in that video just now that to come up, it has to come up kind of slowly, right? So there has to be a sort of a decompression as it comes up. So even under this, sort of like a diver coming up slowly and avoiding the condition called the bends. And so that has to be done for our submersibles as well. Okay, so this is the end of our lecture, but I'm going to be sending this link over to you. Well, like, it's not a link, it's actually the actual video that you'll be playing on your computer right here. It is the IMAX Deep Sea. Now, as I'm telling you this, I'm looking at the bottom of your book, and it says The Blue Planet, the Deep, which is a different production. So I'm not sure if that got changed from the previous years I've done it, but I'm pretty sure if you can't find the IMAX Deep Sea, you can watch the one I send, of course. But I know you can find Blue Planet. That's on Netflix and things like that, and very well done. And so I'll look into that and see if I'm going to change my mind on that. But so far what I'm thinking is I will send you this link right here. You will watch this whenever you can. And then, I mean, you could watch it on Tuesday, regular class time, right after this, and it should be just the right amount of time. It's about 40 minutes. And so we should, it should leave you with the right amount of time as far as class time goes. All right, and then remember next week I will Zoom y'all, I hope, at 10:30, and we'll get a chance to visit a little bit. All right, everybody, hope everybody's well. See you real soon.